0.23 grams of copper, and it reacts with chlorine to produce 2.6 grams of CuCl2. This is how much our product, this is the mass of our product. 1.23 grams of copper became 2.61 grams of copper 2 chloride. How much chlorine is in your compound by mass?
1.3.
How'd you get that number?
I subtracted 2.61 from 5.
Yep. You have to figure out the mass of chlorine. Do not change this into a percent. Go straight from here. You know that you've got 1.23 grams of copper. So divide it by the molar mass of copper. And you've got 1.38 grams of chlorine, so divide it by the molar mass of chlorine. Figure out your moles, do your mole ratio, and you should end up with a formula that is actually CuCl2. So sometimes a question could give you the masses already. Don't do a percent. Go straight to grams to moles, to mole ratio. So which one of those is the smallest? So 0.019 divided by 0.019 is 1, so there's 1 copper. What about 0.038 divided by 0.019? 2. They don't need to be rounded off, they're whole numbers, so your formula is CuCl2. That's probably the step that skipped the most, doing the mole ratio. People find the moles and then they use those as their mole ratios. You have to do your dividing. Once you have the number of moles, divide by the smallest number to get your mole ratio. Any other questions? If we had a flask with aluminum and liquid bromine, the mass before would equal the mass after when we have aluminum bromide. It's in a stoppered flask, so it's in a closed system. No matter can enter or exit our flask. You now know that each element has a mass associated with it. So right now it's saying I've got 1 aluminum on the left side before, and I've got 1 aluminum on the right, but I've got 2 bromines before, and I have 3 bromines after. So their masses are not going to be the same as it's written. So then we've broken this law of conservation of mass because the mass before would not equal the mass after. So experimentally, we know that the masses are equal. There's no change. So then theoretically, we know we have to have the same number of each element. Therefore, we have the same mass of atoms. So how did you balance that? You put a 2. Now, it's going to be balanced. Kind of interesting that it's called balancing when we measure our mass on a balance. Okay? They're equal. The left side of our equation is equal to the mass of the right side. So the total sum of your reactants is equal to the total sum of your products. Okay? Now if you've got a gas product and you don't have a stoppered lid, will you have the same mass? No, because it's going to escape out of your flask, and that's mass gone. You just didn't measure it. All right. So, what did we say stoichiometry was? It's not a guy in Russia. Stoichiometry. That's actually pretty good. What's stoichiometry? The stoichiometric relationship between aluminum and bromine is 2 to 3. Ratios, good. So this is the relationships between substances in a balanced chemical equation. We represent them in ratios. So for example, 2 aluminum react with 3 bromine, or 2 aluminum produce 2 aluminum bromides. We have 5 moles of aluminum bromide. We know that for every 2 aluminum bromides, we need 2 aluminums. Aluminum bromides cancel. Oh, and look, 2 divided by 2 is 1, so I'm left with 5 moles of aluminum. So often you guys have an inkling what the right answer is, but you can't show it. So now I'm going to give you a minute to figure out how many moles of bromine I need. Yes. So you'll notice when we set up our ratio to convert, what we start with, aluminum bromide, is on the bottom. The numbers in our ratio are the coefficients from our balanced chemical equation. Look at me. This is the only time you use those numbers. The only place you use the 2, the 3, and the 2 are in ratios. You do not multiply anybody's molar mass by that number, ever. Gas plus hydrogen gas makes ammonia gas. If we have 2 moles of hydrogen, how much ammonia can we produce? Go. Make sure when you're setting it up that you put the moles under the substance that it's supposed to be. You're not randomly putting it anywhere. And you are supposed to balance it. Then you've got to figure out the ratio. Plug it in. There you go.